This is lesson 21 for 8th grade, and today we're talking about the distributive property. This is another algebraic property, kind of like our Pythagorean theorem that we were talking about, and it's also geometrical. It's more of an algebra topic, but we'll see them both the rest of the year and throughout high school. So another very important property here, and we'll probably be spending some more time on the Pythagorean theorem. Well, I know we will be. And we'll definitely be hitting this year as well. And I should note that we will be splitting lesson 21 into 2 days, at least 2 days, because it also covers order of operations. And order of operations is another pretty big topic that we're going to want to spend a lot of time on. So it's going to take at least 2 days to cover lesson 21. So just a heads up there. Anyway, let's see what we're going to learn today for distributive property. So we're going to want to learn two basic things today. We're going to learn how to expand equations using the distributive property, and we're also going to learn how to factor equations with the distributive property. Now, expanding and factoring are basically opposite processes, and we're going to see how that works in a second here. So, first thing that we like to look at when we're talking about the distributive property is the formula for the perimeter of a rectangle. So if we look at a rectangle here, we have a 12 by 8 rectangle. So if I fill in the rest here, 12 centimeters, 8 centimeters. Alright, so we know how to find the perimeter. We could add up all the sides. Looks like if we do that, we get 12 plus 8 is 20. Plus 12 is 32, plus 8 is 40. So 40 centimeters is what we're looking at. That's one way we could do it. We could also add the length and the width and then double it, or we could double the length and then add double the width. And they're going to show you how this works here. So if we use the first formula, we add the length and the width first. So that'd be 12 plus 8, which they did right here. You get 20. And then it looks like we're going to double that because there are 4 sides to that perimeter. So if we add 2 of the sides, we have to double it to get the full distance around. So if we double this sum, 2 times 20 gives us 40. That's one way we could do that. The second formula says, okay, first thing we're going to do is double the length. Well, our length is 12. So 2 times 12 is 24. And if we double the width, which is 8, 2 times 8 is 16. And then we add these products together, 24 plus 16, and we still get 40. So 3 different ways to find our perimeter there, and we got 40 each time. So that's good. This is pretty much the beginning of the distributive property, and we'll show you where it's headed here. Using this same rectangle, we're going to show you why these two formulas are the same and why they give us the same answer. So, both formulas produce the same result because they are equivalent. They aren't identical, they look different, right? But they are equal because they do result in the same answer every time, no matter what rectangle we're talking about. So, these two formulas illustrate the distributive property, sometimes called the distributive property of multiplication over addition. Don't worry about that. I'm just going to refer to it as the distributive property. And it says the distributive property gives us a choice. It gives us a choice when we're dealing with expressions such as this one. And we just saw how to do that with, well, we did it 2 different ways with our perimeter formula. Okay, so one choice it says is to add before multiplying. So that would be taking our parentheses, we'll add what's inside first. And normally, especially with order of operations, which we'll see, we would normally add first, or do whatever's inside the parentheses first. It's easier to do it that way. We won't always be able to, and we'll show you that in just a second. But yeah, so we would add these two first, 12 plus 8, get our 20, and then double that. And that's where we got that 40 from. Okay? The other choice is to multiply each add-in before adding. So the add-ins are the things that are inside here. Now, the distributive property is shown by these arrows because this basically says 2 times whatever's in here. Alright? So it's not just 2 times 12, It's not just 2 times 8, it's 2 times 12 plus 2 times 8. And that's why these arrows are here. We can distribute this multiplication to both of these numbers. So 2 times 12 plus 2 times 8. And we can see that if we do that, we get 2 times 12, which we did earlier. We got 24 plus 2 times 8, which is 16. So 24 plus 16 still gave us 40. Okay? So that's the choice that we have. We can either add first, multiply by 2, which is probably the easier route, at least for this one. And then the other choice that we have is to go, okay, distribute 2 times 12 plus 2 times 8. So we're distributing that 2 and that multiplication to both of those numbers inside the parentheses. So, either way, you're still going to get the same answer, which we've seen. So that's basically what the distributive property says, that you can distribute your multiplication to both the numbers inside the parentheses there. If there were 5 numbers being added inside these parentheses, you could do that as well. Just distribute your 2 to each of those 5 numbers, which we will see eventually, maybe not today. But if we look at our distributive property in a generic sense, remember that's with just variables, letters, and remember that these letters just represent different numbers, so it's nothing to be worried about. These are just different numbers, we just don't know what they are. Alright, so distributive property says we can distribute this A being multiplied by everything inside here to A times B plus A times C. So, like that, and like that. Those arrows kind of help us remember that's what we're doing. And like I said before, it doesn't matter how much is going on in here, we could do that to each term. So A times B plus A times C plus A times D. So A times B plus A times C plus A times D. You can do that. It also works for subtraction. A times B minus A times C. So these are generic forms for the distributive property. And those are in the book, if you're following along with it. It might be a good thing to copy down if you're not sure or don't think you'll remember this. Alright, so the distributive property works in 2 ways. We can expand and we can factor. Now those were the 2 things. Our main goals for today were to figure out how to expand an equation and to factor an equation. So, when we are talking about expanding, that's when we're using this distributive property. We're going from this side of an equation to this side of the equation. So, that's when we're expanding it, we're making it longer basically. That's when we take our A and we multiply it times B and C. Or in this case, we have a 2 times A plus B. If we distribute that 2, that's 2 times A plus 2 times B. So that's how they got that there. That is what expanding is. Factoring is going the other way. They are opposite processes, remember. So to factor this, we're going to go the opposite direction. We're going to take something like this, right here, and we're going to go the other way with it. We're going to go from this side of the equation to this side. We're going to factor it. We're going to make it smaller. Excuse me. So, the one thing that I like to do with factoring is I like to look at our equation and I say, okay, with whatever's being multiplied here, what do the 2 terms have in common? Well, they have a 2 in common, 2 times A and 2 times B. They're both terms are being multiplied by 2. So you pull out whatever they have in common, and it looked like they had that 2 in common, and whatever they don't have in common stays inside, A and B. Okay? So expanding is going the other way, or no, factoring is going the other way. That seems to be the more tricky one, and we're going to hit that quite a bit this year, because factoring becomes a big part of algebra. In fact, eventually, I know my old math teacher used to call us master factors if we did very well with it. And I hope that each and every one of you can be a master factor. And I know you can. So we're going to do expanding and factoring on both of these, and then another example as well. I want to check my time real quick. Okay, we're doing pretty good. All right, so first thing we want to do is expand letter A there. Now expanding, remember we're going to be doing our distributive property. We're going to make this thing a little bit longer. So W plus M. Now remember, before when we had numbers in here, we could just add them together first and then multiply by 3. But we can't do that because we don't know what W and M are. So here's what our answer is going to be. So if we look at A, I do 3 times W plus M. We're going to take that 3 and multiply it by each term on the inside. 3 times W equals just 3 with a W next to it, 3W. And 3 times M is just like that. That is the expanded version of that equation. Alright? Okay. And we kept the same sign because we were adding, so we're going to keep the same sign there. So, that is the expanded version of letter A. We look at B quick here. We're going to factor, alright? AX plus A times Y. So we have A times X plus A times Y. Now let's do it this way. What we're adding, what do these two terms have in common? They're both being multiplied by an A. So I'm going to go ahead and underline what they have in common. They have an A in common, so I'm going to pull that outside. And they have nothing else in common. So they get whatever they don't have in common, that stays on the inside. So X plus Y. So your factored version is A times X plus Y. That's your factored version of the equation. I think we have one more to go through here. Yes, we do. Alright. Now, if we expand A again, remember we're just going to be doing 3 times both terms. So 3 times X plus 3 times 2. So we're going to do, let's do A here. 3 times X will just come out as 3X plus 3 times 2. Alright, we can simplify that a little further though, because we don't know what 3 times X is, but we do know what 3 times 2 is. So this is 3X plus 6. Alright, I'm going to look at B over here. So we're going to factor this. Alright, 6X plus 9. Remember, factoring, we're going to make it look like something like this, where we have something outside that they both have in common, and then whatever's not in common on the inside. Alright, so what do both of these terms have in common? Well, I'm going to break down 6 into 2 times 3 times X. So this is basically our first term here, 6X plus, and 9 I'm going to break down into 3 times 3. Now it's a little bit easier to see what they have in common. So, remember, we're going to get something like what they have in common and whatever's left on the inside. So, looks like they have just 1 3 in common. So we're going to pull out 1 3. And what's left on the inside? 2 times X. And 1 3 is left over here. So, 3, 2x plus 3. That's your factored version. And if we went ahead and expanded this, it would be 3 times 2x, we'd get 6x, plus 3 times 3 is 9. So we're going to hit this quite a bit tomorrow. It's a new topic, I understand that, and we're going to make some sense out of it. Alright, we'll see you tomorrow.